Hi Ravens, here we go. We are on the very last of the gas laws video presentations, and this is the homework problems for the combined gas laws from your notes packet. Okay, so what will be the new volume if 125 milliliters, so that means our original volume is 125 milliliters of helium gas at a temperature of 100 degrees Celsius. So T1, 100 degrees Celsius plus 273, pardon me, is equal to 373 kelvins. And it is at a pressure, so P1 is equal to 0.981 atmospheres. And it's going to get cooled to T2. It's going to get cooled down to 25 degrees Celsius. So 25 degrees Celsius is the 273 equals 298 kelvins. Okay, and its pressure increases, so P1 goes up to 1.15 atmospheres. Okay, and you're being asked for the new volume, and whoops, this is P2. And you're looking for V2 is our unknown. Okay, so this involves everything, pressure, volume, and temperature, so therefore let's do everything. So that's P1, V1, T2 is equal to P2, V2, T1. And we're looking for V2, so we're going to isolate variables. V2 is equal to P1, V1, T2 divided by P2 and T1. So plugging things in, P1 is 0.981 atmospheres. V1 is 125 milliliters. And T2 is 298 kelvins divided by P2, which is the 1.15 ATMs, and T1 is 373 kelvins. And when we're using combined gas laws, just make sure Kelvin cancels Kelvin, ATM cancels ATM. Our ending unit's going to be in milliliters. We're not asked for anything any type of specific volume, so milliliters is fine. When I do the math and I multiply and divide, I'm going to end up with 85.2 milliliters. Okay, and so that problem is done. Now let's go on to the second one here. And this time we have what will be the volume. So again, V2 is going to be our unknown. V1 is 495 milliliters. And it's an ideal gas at 27 degrees temperature. So T1 is 27 degrees Celsius plus 273 is going to equal 300 kelvins, and P1 is equal to 1.05 ATM. And it's going to be cooled down to a new temperature of 15 degrees Celsius, and that is with Kelvin, so plus 273 will result in 288 kelvins. That's a 2. And the new pressure, P2, is equal to 0.997 ATMs. All right, I'm going to use the same formula as we used up above. So V2 is equal to P1. It's slowing down on me quite a bit. P1 V1 T2 over P2 T1. And plugging everything in, we get P1 is 1.05 ATMs. V1 is 495 milliliters. And T2, this is our cooled down temp of 288. Come on, 8. There it is. 288 kelvins. And it's divided by P2, which is 0.997 ATMs. And our T1 is 300 kelvins. And that comes out to equal 500.5 milliliters. Okay, and we didn't really see too many huge drastic changes and things, so it makes sense that our volume did not change drastically. All right, at this point you are ready for that mixed gas laws worksheet. Don't forget to check your answers with the answer key on Moodle, and email me if you have any questions as always. All right, take care, Ravens. See you later.